Just a few thousand years ago, our ancestors did not have written language. We're almost the same as those humans biologically, but what goes on in our minds would be totally alien to them. Growing up in a world with paper and pens has changed us. We can follow a chain of thought beyond the extent of our working memory. We can think abstractly and analytically. We can build on ideas of people we've never met and leave our own for posterity. But it wasn't natural selection that gave us those abilities. It was other people. We've inherited that astounding power to create tools which shape our own thoughts, the power to transcend our own mental capabilities. Now, written language was the work of whole cultures, but what excites me most in my work is that small groups and individuals can also invent transformative tools for thought. I think of Playfair and statistical graphics in the 18th century, or of Mendeleev and the periodic table in the 19th. And tools like this are discovered as much as invented. Their power lies in distilling deep domain insights like periodic law into external forms that we can use to think and communicate. And one of the great dreams of the personal computing revolution was that we would all have not only our own computers, but also our own software, exquisitely tuned to our own purposes. But instead, we sleepwalked into two accidental tyrannies. The first is the application model. Because software is expensive to build, developers need to capture as large a market as possible, and that's led to one-size-fits-all packages. You can only adjust the knobs that the developer gives you, and your tools can only be combined at the junctions the developer anticipated. We live in a landscape of walled gardens, and the result is that our workflows often don't work the way that we wish they did. The second is programming itself. Rather than creating a new universal literacy, we created a specialist priesthood. The familiar version of that complaint is that end users are relegated to being passive consumers of the dynamic medium. But I'll also make the case that even within the tech industry and within HCI research, programming culture is accidentally holding back invention. Now, though, I see some new paths out of these traps. So let's focus first on apps. Now, of course, the application model is a familiar villain in our field. People have been trying to break us out of these silos for decades. And one major thread of work, end user programming, aims to allow non-professional programmers to build their own software. And that has turned out to be awfully difficult in practice, as spreadsheets are the major success story. But it's been hard to produce others. Until recently, of course, now we have coding agents. Everybody can build their own software, right? Well, maybe. As I look around in early 2026, I see non-programmers building things like personal dashboards and automations, writing scripts to connect or combine data from different incompatible systems. We're already knocking some cracks into the app silos there. And of course, I see a lot of fun toys. But all in all, I mostly see non-programmers using agents to create glue code and tools at the periphery of their real work. That's fantastic. And I'm sure we'll see people build ever more ambitious personal tools, but I want more. Let's play this trend out further. Now, as far as I know, filmmakers aren't yet using coding agents to personalize their editing workstations. And musicians aren't yet using coding agents to personalize their engraving software. So what would it take to let non-programmers improvise improvements to complex interfaces at the very center of their work? I want to see the dream of personal dynamic media fulfilled for the most important parts of their practice. Those parts often take place in extremely complex mega apps. A filmmaker will spend thousands of hours in Adobe Premiere. A composer will spend thousands of hours in Sibelius. Apps like these support plugins, but they're locked in little boxes. Plugins are allowed to render an interface into a modal or perhaps a sidebar. But if the user wants to improve the primary interactive surface of those apps for their personal workflow, they'll need to recreate all of that complexity. Neither today's coding agents nor their typical users are prepared to rewrite Photoshop on the fly just to add a new kind of brush tool. So if we want to free ourselves from siloed monoliths, we'll need a more malleable substrate than today's 0-to-1 coding agents. Researchers working on this problem know that, of course, and we've seen systems from Smalltalk to WebStraits to Potluck proposing principled architectures for user extensibility. But the trouble is that none of these approaches is as versatile and accessible as that text-to-app workflow. So can we find some happy middle with enough structure to let users adapt complex software without rewriting it completely from scratch, and yet with enough versatility and accessibility for non-programmers to use. Now, it makes sense, by the way, that plugins in apps like Photoshop are locked in little boxes. Their main interactive surfaces are enormously complicated. If plugins were allowed to just start reaching in and changing things, then chaos would quickly ensue. Safe and expressive extensibility would require such a complex API surface that plugins would become incredibly difficult to write. So it is much easier to just give plugins a panel they can fully control. Having said all that, though, I think we can learn from an interesting exception to this rule, Obsidian. So to my knowledge, it's the only deeply extensible GUI word processor that has ever reached production. Like other word processors, plugins can add custom themes and commands and interfaces in isolated panels, but unlike other word processors, Obsidian's rich text editor is built on an open source framework with an unusually composable architecture called CodeMirror. And so, uniquely, Obsidian plugins can arbitrarily extend the behavior and presentation of the rich text editor itself. For example, this LaTeX Suite plugin shows me an inline preview of rendered LaTeX while I'm editing its source. And it also changes the behavior of keyboard events. If I'm inside of a math expression and I press tab, it jumps my cursor just outside the current brace scope. It's quite invasive. Now, most Obsidian plugins don't extend the editor GUI. Most Obsidian plugins just add custom commands or isolated panels, and I think that's because extending the editor itself requires some very complicated programming. The complexity does seem necessary. It's what makes the safe composable editor plugins possible. And we'll talk more about how actually that works shortly. But it is a significant deterrent. I'm an experienced programmer, and every time I've started noodling on an editor extension for Obsidian, I quickly got discouraged by how much intricate work that requires. So again and again, I've scoped back those ambitions or abandoned those projects altogether. But coding agents have changed that. They can handle that complexity for me. In fact, in the past few months, they've become good enough that I can create complex editor extensions without supervising the code. That's end-user programming territory. And now my idiosyncratic word processing dreams can be realized more or less on a whim. Let me show you.
I spend a lot of time reading outside. Now, I want to read actively, which would normally mean writing in a notebook while I read, but it's hard to balance that on my leg while I'm in a chair like this, so instead I usually put a microphone in my ear and ramble while I read. The trouble with that is that my comments really need to reference particular passages in the book to make sense, and it's hard to do that with audio. So I made a new tool to help me with that. We're not outside right now, so I'm going to have to show you a digital book, but just imagine that we were reading a physical version of this book right here. I might be flipping through it, and I might encounter a passage like this. And maybe I have a comment about this particular passage. Inspired by Canon Cat, I realized that a sequence of 3 or 4 words like this can uniquely identify pretty much any point in a book. So let me just start an audio recording. And now as I'm reading through, I can just say to myself, quote, though only 3 years older, and then I can ramble whatever observation I have about that, and I can just keep reading through, and if I find another passage that seems relevant, I can say, quote, we already feel the effects, and then I can say whatever I have to say about that, and go on, maybe record for an hour like this, come back to my computer, and here's what I might do. So I can copy this audio and switch over to Obsidian, where I have prepared a special plugin. Here we're in the middle of a markdown document. I've got an image and a block quote with a synopsis of the book. Now I can just paste the recording I just made and transcribe it. Now I have a transcript, and of course, transcribing audio is nothing special, but you see there's something interesting going on here. These places where I pointed to a passage with my voice, they're highlighted in yellow, and there's a special button next to them. Now this is still just a markdown document. If we look at the source here, we just see normal plain text and a block quote and an image. But the styling is being applied in the live editor, and there's a button. And if I click the button and I point the editor at the EPUB I was just reading, then it can ground those quotes in the particular passages of the text. We see that that quote directive was replaced with the block quote in the EPUB with a fairly elaborate link into the book. And there's also this additional behavior with that fairly elaborate link that actually navigates the book to that specific position. And part of what's nice about this is that from this point, it's just plain text. So I can extend my comments and add another comment or move this stuff around in the document, copy it, paste it, just treat it like a material. So that's the first plugin. But once I had this, I realized that I don't want to just completely lose the audio. There was some interesting affect in that. Here we just have plain text. So I made another plugin. I can demonstrate it with this audio file that's actually me talking to myself about the design of the plugin that we just looked at.
They exist. The way that works.
Here I'm just rambling to myself in a car about the design of this plugin, how it should work. And again, I can transcribe this. Here I've got something pretty interesting. This is a new kind of markdown directive that I've introduced called a transcript directive. I can press the play button. We get audio playback synchronized with a textual transcript. This is inspired by some old work from Steve Rubin that some of you might recognize. I can hold down Command and click anywhere in the transcript
sequence
to jump around.
The voice recording into my computer level. The idea
but this is still just markdown. So looking again at the source, we've just got plain text. This block is wrapped in this special directive with 3 colons. This is a markdown extension directive. And now I can do some interesting things. There's sort of an algebra of edits that this plugin introduces. So I can go here and start making some new comments of my own in the middle of this transcript. We see that it's actually split the transcript block. Here, this old one now has an end time. This one has a start time. I can copy from in the middle of a transcript, like this paragraph here. I can make a new file, paste, and here it's pasted a segment of the transcript that begins at a particular time and ends at a particular time. I can still command click. It still works. Switching back to the original file, I can delete in the middle of the transcript. So jumping here, say, in the middle of this 5-word sequence, we see that it's inserted a special new kind of leaf node. And if I start playback from here,
5 words,
it will jump over this break.
The idea is that,
and it also jumped over the deletion.
Should uniquely identify
like a fairly complicated bit of new markdown behavior that's just been introduced into the middle of this pre-existing editor. Now from here, of course, the next thing to do is to combine these plugins. So let's turn them both on at once, and we can see that now this place where I've included a quote directive in the middle of this ramble, it's got that special highlight. We have the styling from the quote plugin in the middle of the styling from the transcript plugin. Now this quote directive I can't actually match because it's just an example that I was describing. It doesn't correspond to a book. But let me just make a new demo file, and I can again paste in the audio file that we made earlier, and this time transcribe it with the transcript plugin. And now I have a transcript of that recording that we made together, like before, but unlike before, it's wrapped in this new transcript directive, which means that I can command click and start playing from
whatever observation
anywhere in the file.
I have about
Hear the
that.
audio,
and I
can edit the transcript, and the audio aligns
ramble
with the
whatever
edit.
I have about
But that new behavior combines with the old behavior of this quote leap plugin. I can click the quote and resolve those embedded quotes, and we still get playback of the transcript around the quotes.
Ramble whatever observation I have about that, and I can just keep reading hour like this, come back to my computer, say to myself,
and in fact,
and then I
the
can
playback
ramble
jumps
whatever
over the
I have about
quotes.
that, and I can just
But
keep
now I
reading
have these
through.
block quotes, and I can jump to the appropriate spot in my book, and so on. So I kind of get the best of both worlds. I get my audio transcript,
Passage
and I
that
also
seems
get
relevant. I can
my
say
quotes
and then
that
I can
are
say whatever I
directly
have to say about
within
that.
the book. So I can see what I'm referring to while I listen to myself ramble. These two plugins are working together to deeply modify the behavior of this WYSIWYG text editor.
Now, what's exciting about that demo isn't the interaction design of those particular plugins. That's not what I'm here to demonstrate. You could imagine seeing each of those interfaces as part of some workaday HCI paper demonstrating a research system. Now, what's exciting about that demo is that this isn't a research system. I brought those behaviors into Obsidian, which is a production word processor that I actually use. If they only existed in some writing environment prototyped for a paper, then I wouldn't be able to use them in my own typical word processor. I would have to use a writing environment that is usually only polished enough to run a user study. So in this way, app silos hold back invention. If I want to contribute a new interface idea to something like Photoshop, then I'm forced to re-implement all of the pre-existing functionality of whatever the best app in that domain is, and then I get to add my own idea as a cherry on top. Before I can do that, I have to pay this enormous tax to escape research purgatory. And it gets worse. So suppose that each of those interactions that I just showed was implemented in a different paper by a different author. If I wanted to use both behaviors at once, like I did at the end of the demo, then I'm simply out of luck because each behavior is trapped in its own system. What's different in this demo is composability. Those complex new behaviors compose with Obsidian's pre-existing complex editor and with each other, and without any special knowledge or coupling. It's nice, too, that coding agents built these behaviors for me, even if perhaps a bit imperfectly. But it's the combination of composability and coding agents that's particularly exciting to me, because coding agents without a composable architecture give us these kind of 0 to 1 silo apps, and composable architecture without coding agents makes novel plugins too costly for all but the most devoted and experienced developers. Together, though, they might mean that non-programmers can riff at will on pre-existing complex interfaces with plugins like this. Now, we've been talking in terms of Obsidian because that's the high-level package that a user experiences, but the real credit for its editor's composability is due to CodeMirror, an open-source framework by Marijn Haverbeke. Now, rather than building a text editor and later designing a plugin system on top of it, Marijn designed a text editor that is made out of plugins. Let me explain. So Obsidian is a WYSIWYG markdown editor, but CodeMirror doesn't know anything about markdown or images or bulleted lists or links or tables. Everything you see beyond plain text in the Obsidian editor is a CodeMirror plugin. So when a user adds a CodeMirror plugin of their own, they're using exactly the same primitives that the Obsidian developers use to develop their product. CodeMirror defines a rough physics of the medium. There's basic models for text and state selection with transactional updates. Pretty much everything else, how text looks, what happens when you click or type, what state is maintained, what appears alongside the text, all of that is described through facets. The facets are a composable structure that define how independent plugins can safely contribute to the same concern. Plugins don't act on the document, they declare what they want. And then for decorations, for key bindings, for state updates, and for everything else, CodeMirror's physics define rules for combining and enacting those declarations. Let me show you how that works in terms of the demo that we just saw. So here on the left, we see those two plugins acting at once on a quote directive inside of an audio transcript. One element of that behavior is visual styling. The audio transcripts use a small monospace text, while the quote directives have a yellow glow. Both of those things can apply simultaneously. CodeMirror's editor view exposes many facets that plugins can use to control the behavior and appearance of the editor. One key facet is called decorations. The audio transcript plugin declares that it wants to decorate lines 5 through 18 with the transcript CSS class, and then separately, the quote leap plugin declares that it wants to decorate a certain character range with a different CSS class. The decorations facet combines all those decorations and combines them into the DOM. We use a similar strategy for the buttons to the left of the text. But what about resolving quotes that are inside of a markdown transcript? You can see that before and after on the left here. Well, first off, the audio transcript is part of the editor's model. It's just a markdown syntax extension, so the data is still in the markdown document. It's not sequestered in some separate store. That means that other plugins can see it. So when you press the button next to that quote directive, the plugin parses the markdown, sees all of those quote directives as usual, and then replaces them with the resolved quotes from the book. But notice that the transcript blocks get split around the block quotes. We can make that happen because editor operations also compose explicitly. There's another one of those facets. This one's called transaction filter. Editing operations, like the quote block replacements, they're described declaratively in transaction data structures, and then those transactions get passed through a pipeline of transaction filters declared by plugins, which can then transform them. Now, the audio transcript plugin doesn't know anything about the quote lead plugin, but you might remember from the demo, even in the audio transcript plugin, you can position your cursor in the middle of the transcript and insert a new line to split it, and then insert some, just normal markdown in the middle of the transcript. And because of that feature, any insertions or replacements that happen in the middle of the audio transcript cause this kind of splitting behavior to happen. The plugin declares a transaction filter that watches for insertions inside of transcript blocks, and it reacts by splitting around the insertion. Now, all this declarative machinery is really quite complicated to implement. You can see why it's created such a high barrier for plugins in the past. But happily, I didn't need to write this code, as coding agents did it for me. Now, you could do this kind of thing in other extensible text editors like Emacs. In fact, if you were in Emacs, you would just manipulate the buffer directly in one line. But when two plugins touch the same region, you get these like nightmare stories. Like org mode had a multi-year rewrite of its folding code, which kept breaking lots of other packages, and they ended up having to pile all these workarounds on top of it. And the idea is that CodeMirror has this declarative approach, which replaces a patchwork of unrelated editing extensions and mechanisms with a consistent composable pattern. So now that I've tasted it, I want this kind of extensibility, not just with my rich text editor, but for my design work, for my music, for my reading. If CodeMirror defines a physics of rich text editing, and that physics makes it possible for plugins to independently extend this complex user interface, then what would an equivalent physics look like for a Figma or for a Sibelius? Or actually, wait, before I try to answer that for Figma or Sibelius, I just said I wanted this kind of extensibility for reading. What software would I even aspire to extend for that? Apple Books? Preview.app? Maybe PDF Expert? This problem is actually worse than the need for extensible Pro Tools. Serious readers don't have the Pro Tools in the first place. What's special about dynamic mediums is that they behave and respond. When I'm iterating on a design system in Figma, I can see in real time how my choices affect layout and weight across every screen of the app I'm designing. When I'm mixing a track, spectrum visualizers let me quickly spot and fix muddy segments. We can tell similar stories in climate modeling and genomics and so many other domains. The medium takes on some of the cognitive load, and so we can explore and refine our ideas closer to the speed of thought. But meanwhile, our reading environments have evolved remarkably little. And yet there's so much room for them to evolve. We often fail to absorb key ideas from what we read without noticing, and we forget details we found fascinating. Just last week, we write notes in the margins and then struggle to see across texts. We're not really making use of the dynamic medium for any of this. We're just mostly working with pictures of paper on screens. In other domains, the medium dances with us. It provides active support for difficult creative work. But in scholarship, for the most part, the paper lies inert, while we shoulder the full cognitive load. Echoing Engelbart, the bricks are still strapped to our pencils. Now, you could say maybe there's something special about reading that prevents the transformative tools we've seen in other domains. Maybe there are no augmentations worth pursuing. But in fact, HCI researchers have built quite a few interesting augmented reading systems. Here's Skim by Falk et al., which highlights and color codes key sentences containing goals, novel contributions, and results. Here's CiteC by Chang et al., which color codes citation links so you can see which ones you've saved, read, and cited. Here's Papios by Kim et al., which lets readers quickly jump between a research paper and the aligned segments of an associated video. Here's Liquid Text by Tashman and Edwards, which supports parallel reading by letting users collapse parts of documents. And SpaceInk does the opposite. It lets users expand white space around lines to make room for marginalia. Here's one called Quantum Country that I developed with Michael Nielsen, which integrates a space repetition memory system into the reading experience to make it easier for readers to remember what they read. Lots here, but as interesting as these individual projects' ideas are, they don't quite accumulate. Each interaction is trapped in its own reading environment, stuck in the same research purgatory that I mentioned earlier. If you want to use CiteC's color-coded scheme, you have to use its prototype as your PDF reader. And then if you want to use features from every one of the other systems that I just mentioned, you'd need to switch wholesale to their readers. So by way of generalizing from CodeMirror, could we define a physics of reading environments, one which could simultaneously support all of these disparate augmented reading ideas, plus untold more yet to be invented? And now, let's have some more demos.
Here we have a prototype malleable reading environment. This reading environment uses the same philosophy as CodeMirror: facets, declarative contributions, system manners combinations. But as we'll see, reading surfaces some new compositional needs that editing didn't have. Now let's play with some plugins. Here's a version of Skim by Falk et al. Sentences light up with colored backgrounds, objectives in green, methods in blue, results in orange. They're classified by their rhetorical role in the paper. The plugin works by declaring decorations on text ranges, just like in CodeMirror. And here is a slice of Cite C by Chang et al. Citation markers tint by your reading history. Green means you've read it, and when you hover one, you can see a card with the paper's details. These are two extensions representing original papers by two different authors composed on the same text. Neither one knows about the other. The system merges their declarations, the colored backgrounds, the tinted brackets, the input events, through the same kind of facet mechanism that I showed you in CodeMirror. Now, decorations paint on the text, but some reading augmentations need to live alongside it, anchored to a position in the document, but rendering outside the text flow. So here we have a margin notes plugin, which allows me to point to any point in the text and create a margin note. This margin note is anchored to the vertical position of its target paragraph and to the right edge of the page. The extension doesn't calculate that position, it just declares, I want a widget anchored to these semantic locations, and the system handles the rest. So now I can turn on another plugin. Here's Papios by Kim et al. This plugin links sections of the paper to moments in the author's corresponding conference talk. It also declares anchored widgets, positioned in the same kind of declarative fashion. But Papios doesn't know anything about my margin note plugin. It's just that because they both contribute to the same anchoring facet, the system makes sure that these widgets don't overlap. And the same anchoring primitive can support things beyond marginalia: floating toolbars, contextual panels, anything that an extension wants to place alongside a document position. Now, so far, we've seen extensions that add information, colors on the text, widgets alongside it. The document itself has stayed the same underneath. But some of the most interesting reading augmentations change how content is rendered. Here we have a riff on liquid text by Attachment and Edwards. When I hold the Command key and scroll, I can compress sections of the paper spatially, pushing content together. Notice that the rhetorical colors, this green here, it compresses into a sort of visual fingerprint inside the collapsed region. You can think of decorations like a fragment shader that composes with these changes to the document's geometry, which is sort of like a vertex shader in a graphics pipeline. This is a spatial transform. It changes where content appears on screen. But notice also what's happening to these anchored widgets. These anchored widgets don't know about the liquid text plugin. They just ask the layout map, where is my anchor right now? And the layout map accounts for that spatial transform. They don't know the document's been reshaped, but the widgets do follow the geometry. Because this architecture cleanly separates what to show from where to show it, we can render the same document multiple times in different ways. This mini map reads the same decoration facets as the main view, the rhetorical colors, the citation markers, but it renders them inside of a compressed overview. Conceptually, it's like a second render pass of the same pipeline.
Composable architectures and coding agents, in combination, may help us break down the silos around our most complex apps, but I'm not satisfied with just combining the balkanized interface ideas that we already have. I want a wild flux of new ideas. I think we've barely scratched the surface of what we can do with dynamic media. Despite all of the manic energy in the tech industry and all of the prestigious HCI conferences, the pace of meaningful invention in user interfaces strikes me as remarkably slow, and the level of imagination remarkably tame. I want new answers, new questions, and ideally both at once. In the early days of the personal computer, the transformative user interfaces were invented by field-crossing weirdos like Engelbart and Sutherland, Kay, Simone Atkinson. They had PhDs in the sciences because building anything was so hard back then, but really they were wildly imaginative designers. The software industry grew much faster than the supply of polymathic geniuses, and so by the 80s, most programmers left to their own devices were building outrageously user-hostile software that was filled with technical jargon. And so in his landmark book, The Inmates Are Running the Asylum, Alan Cooper proposed this new role, the interaction designer, who would work alongside the programmers to build software that better fit user needs and abilities. Specialization worked. I mean, most modern software really does make a strong effort to understand user needs. And now that interface design patterns and practices have developed, they've spread so widely in the culture that many programmers can create tolerable interfaces on their own. But I say, the inmates are still running the asylum. Now, Cooper was worried about an accidental tyranny of programmers subjecting people to comically bad user interfaces. I'm worried about an accidental tyranny of programmers holding back imagination in user interfaces. I want weird, courageous, idiosyncratic, alien. Yeah, we're living through the astounding advent of machine intelligence, and that's plenty alien. But we've crammed all that power into chat interfaces that have barely evolved since the IRC clients I used as a teenager. Where's the invention? I think the central problem is that invention in the dynamic medium requires too much programming. To invent a new user interface, you need both imaginative design skill and fluent technical skill. Very few people possess both. And worse, those two usually aren't enough. Much interface invention also requires deep domain insight. I think about Steinberg inventing the timeline editor in Cubase after years as a musician and producer, or Bricklin inventing the dynamic spreadsheet while at Harvard Business School. Now, of those skills, you might suppose that bold new user interfaces are mostly bottlenecked on imaginative design work and deep domain insight. And so you might expect to see those skills most emphasized in the culture. But if you visit community events around interface invention or the future of personal computers or academic HCI, you'll quickly notice that pretty much everybody's a programmer by training. And they're also programmers by culture. Most will have studied at a formal analytical science program, not the wild-eyed studios of a design school. Not incidentally, that includes me. I suspect we're in this situation because of a deep asymmetry between these skills. Programming without design or domain insight can yield working interfaces, though often boring or flawed ones, while design or domain insights without programming get stuck on the drawing board. So, at least for solo invention, roughly all working interfaces are created by programmers who may or may not have those other skills. If new interfaces are mostly bottlenecked on imaginative design work and deep domain insight, this asymmetry puts selection pressure on the wrong skills. When I complain about the slow pace of interface invention, people often tell me this is really a problem with the market. Consumers reward easy, familiar interfaces, not weird ones. It's a lucrative industry now, and so it's become commercialized and professionalized. But you know what? The future of computing meetups and HCI conferences, they're full of people who don't care about those things, who yearn to build their own castles in the sky and have these great ideas they want to express. It's just that with love and as part of that scene, the results are often underwhelming. I think this is because the scene is wildly overweight on programming and underweight on domain insight and design. Now, if solo invention selects for the wrong skill, what about inventing in teams? Cooper thought we could get out of this through specialization. Well, if programmers working together with designers, maybe one of them or maybe a product manager will have the domain insight too. And this had worked out okay for most software. I think most software is just theme and variation, professionals applying well-known patterns. Novelty would actually get in the way, but I want to talk about invention. And there, I think specialization has worked much less well. Teams put non-programmers in a position of dependency by default. If a designer wants to invent a novel interface, they usually can't make a working prototype without pitching others to help. And it's tough pitching too. They have to show something fake and lean on their colleagues' imagination to fill in the blanks. For designers with modest programming skills, prototyping often remains too slow and difficult to justify that opportunity cost. I've seen designers stuck here for years, often referencing some concept they have in their head, but they've never been able to realize in a form that others can understand. So it might sound like the problem is that designers are just constantly pitching brilliant ideas, but they're getting shot down by their short-sighted colleagues. I think the deeper problem is that this dynamic tends to prevent those ideas from ever becoming brilliant in the first place. Why would we expect that people can develop and pitch a great idea for a novel interface without ever using and iterating upon a real working version of that interface? Non-programming designers are trying to invent something in an interactive medium without being able to make something meaningfully interactive. So much of invention is about intimacy with the materials and about tight feedback and about sensitive observation and authentic use. So it's a catch-22. To enter into proper dialogue with their medium, a non-programmer needs to get help from a programmer. And that generally requires the idea to be at least somewhat legible and compelling. But if they're doing something truly novel, they often can't make it legible and compelling without being in that close dialogue with their medium. So, modern software design culture often turns to visual craftsmanship rather than novel dynamic representations or interactions. I think that's because visuals are the domain where designers can tinker intuitively without the frustration of depending on others to develop their ideas. It's sort of like the design equivalent of an alienated programmer hyperfixating on making the code really clean. Each practice is fine and necessary in appropriate quantities, but can easily become a self-protective retreat from the medium's true potential. Also, this is a bad situation for programmers. They become inadvertent gatekeepers. I've been in this position with colleagues. They explain their idea, and I probe and I riff, but I still don't really see what they see in it. From here, I have two bad options. I can demur, which often effectively just blocks my teammate, or I can acquiesce, subordinating my own priorities to an idea that, rightly or wrongly, seems less promising than the ones I'm already addressing. But now I see cracks in the walls. I think coding agents will end the accidental tyranny of programmers and interface invention. I think designers and domain experts will increasingly free themselves from their dependence on programmers in the early stages of invention. They'll finally be able to get their hands on the dynamic medium to iterate and prototype concepts directly. I've been seeing it. I spent 2025 collaborating with two talented designers. Their story with coding agents this past year has been truly wild. I think the impact on my collaborators has been much greater than the impact on me, despite the fact that I'm now building perhaps 10 times the speed, so much stuff, so fast. Unlike me, these two started their careers in design and spent their formative years in the arts culture. They can program a bit, but the process is, or rather was, really slow and difficult enough to pose a significant barrier. Now, at the start of 2025, coding models could implement small, one-off design ideas, but their outputs would just fall apart after a couple of iterations. And at the end of the year, my collaborators were routinely prototyping novel interface ideas, and they would sustain that iteration across weeks. I'd often check my messages in the morning, and I would find some stunningly elaborate prototype condensed from dreams in a single late-night fugue. For example, for much of the year, our interface sketches gestured at an exotic interactive content layout system. We shied away from fleshing it out because it had the air of a big, scary project. But then I woke up one morning to a working implementation because one designer and an army of coding agents had just figured it out together overnight. And that very same week, I watched with amazement as the other designer I was working with transformed pencil sketches of a dynamic 3D data visualization into this captivating prototype that ran against real data from our system. Now, this arc has totally changed the nature of our collaboration. At the start of the year, my collaborators had to mostly go through me to get their ideas prototyped at enough fidelity to seriously use. And with 3 people designing and 1 person programming, there just wasn't enough programming to go around. It's tough for everybody. It turns me into a gatekeeper and my colleagues into salespeople. But now increasingly, they can tinker with their own ideas and prototypes. On a couple occasions, my collaborators prototyped an idea and I could see, gosh, you were gesturing at this a while ago and I didn't get it. But now I don't have to get it. I'm not blocking their early expression and iteration. And like I described earlier, this story isn't just about me being too dense to appreciate the beautiful early ideas from my collaborators. Often a designer can't really understand their own inkling until they can get their hands on it and tinker with it. Coding agents created a safe space for noodling for them when their ideas aren't yet coherent. The old dynamic demanded all this clarity and legibility up front. I wonder how different Ted Nelson's story might have been in this world. He spent 50 years chasing this parallel universe version of the World Wide Web in which every piece of writing lives in this living network with everything else. He had that wild imagination I really want to see in this scene, but he didn't have the technical skills to prototype his ideas. So he wrote whole books about them, pushed the concepts further and further without the real feedback that he needed from these systems. And so finally, after spending his whole career fighting for the buy-in that he was needed to experience his own ideas, he got some of them implemented, and they just weren't as powerful or compelling as advertised. I think that shouldn't surprise us. We shouldn't blame him. Invention takes iteration. It takes contact with the medium, and he didn't really have that opportunity. I wonder, what if he did? Increasingly, today's designers do. It's clearly a source of childlike joy for them. One of my collaborators, Neo Ono, shared this on their experience. I'm just going to read a quote from them. Vibe coding unlocked something in my mind or in my latent personality matrix. I'm reminded of descriptions by people who feel like they were fundamentally changed by martial arts or an esoteric practice, like something inside of me realigned and connected me to an inner conduit of energy that had lain dormant. I feel unleashed in a way that changes my sense of self. There is an unambiguous before and after. I feel free to act, to express myself. I feel the body electric is as perfect a summation of this feeling as anything. Every designer I know has spent ages haunted by beautiful ideas without enough buy-in to try them properly. Well, now they can just try things out. I have to imagine they're all champing at the bit, sick of waiting around for others to express their ideas. Now, the tech world is drowning in noise about coding agents. Some people say computer science undergrads are screwed. Idea guys are going to build and ship everything by themselves. Others say, oh, that's just hype. But whatever. What I want is more imagination and invention in user interfaces. And for that, coding agents can make a huge difference, even if non-programmers can't bring their prototypes all the way to production. The bottleneck here isn't that we're constantly seeing these amazing new user interface prototypes and research systems, and yet the foolish market just won't bring these systems to production. That would be a great problem to have. I want to increase the imaginative flow into the top of the funnel. That early stage puts less pressure on software quality. A prototype just has to be real enough to let the designer feel how their ideas play out in an authentic context and to communicate clearly to others. Coding agents are already good enough to produce that level of prototyping for some ideas. And then once there's a team, high-fidelity prototypes communicate ideas about dynamic media much more effectively than what most designers use now. Unlike static artboards and click-through demos, these prototypes can clearly specify novel dynamic behavior. Bas Ording invented iOS's inertial scrolling and rubber banding using Macromedia Director prototypes with hacked-together scripts. None of that code shipped. But who cares? It defined the essential feeling of computing for a generation. If the last year's trend holds, we won't need to worry too much about these technical challenges. I'm actually much more worried about dealing with the aesthetic and cognitive challenges. Working with coding agents all day leaves my attention fragmented, unfocused, impulsive. I'm busy waiting. I'm constantly bouncing between 5 different workspace tabs. I'm flushing and reconstituting my working memory. I'm moving quickly, but I'm never in flow. My design collaborator shared another quote on that feeling, a striking counterpoint to their earlier quote. Here's Neo again. I live in an eternal present. No memory, no plan. Every minute, my attention lunges at something else. It's hard to recount what even happened these past few months. For all this activity, I feel bereft of outcomes or memories. I feel disembodied, so my embodied life is in disrepair. My home is my screen, so my living space is dusty and incomplete. I feel robbed of agency. I can scarcely recognize my own goals, let alone act on them. It's like forgetting a past life. The world feels like a blurry backdrop for my screens. It's all desktop wallpaper. There's a deep pleasure in making something by hand, replaced here by a kind of anxious, scattered freneticism. Building has become so easy that it's now an oddly dangerous temptation. My collaborators and I have all found ourselves accidentally volleying with agents as a way to avoid thinking carefully about a problem. Well, these costs are real, but we endure them for the moment because coding agents are great news for invention. Even as an experienced programmer, I move so much faster that I'm trying all kinds of ideas I just wouldn't even have tried a year ago. That said, I am grappling with some uneasy questions about my own practice. I've spent more than 2/3 of my life programming and a little over a third doing inventive design work, so it probably shouldn't be a surprise that I'm still a much stronger technologist than I am an inventor. I think the modest success I've had in the latter role is mostly due to my generalist skill set rather than to the reach of my imagination. Designer programmers are just kind of rare, and that's given me a pretty unique advantage. But I think, or rather, I hope that this advantage is actually just going to disappear in the next few years. And where will that leave me and other people like me? If I'm honest, I don't think I'm as imaginative as the designers I most admire. My expressive range for visual representations is much narrower, and I move a lot more slowly when rendering and iterating on interface ideas. Some of that is just a matter of having less practice, but that's only part of what I mean when I say the interface invention scene is overweight on programming and underweight on design. By design, I also mean something broader than professional practice. I also mean bold imagination and inspired creative energy. Plenty of programmers have that energy, but much of what programming culture instills and rewards is more analytical and pragmatic. My decades as a programmer instilled this formal mindset that seems to act against wild-eyed generativity. My mind automatically moves towards abstraction, generalization. It's a superpower when it's time to systematize. I can receive a vague, ill-defined idea and ask the questions that allow it to actually work coherently, but it puts too much pressure on really early ideas. I envy the way that some of my designer friends can throw spaghetti against the wall and tinker with an appealing idea without worrying about the formal rules it implies. So, What now? We've spent decades building HCI programs that mostly look like computer science departments with design electives. But if we're moving towards a world where invention is bottlenecked more on imagination than on technical expertise, we may have that backwards. We may need programs that look a little bit more like art school with technical electives, learning to develop ideas from intuition before being able to express them precisely, to discover by playing with the material. And as for myself and others in this scene who grew up in programming culture, how should we adapt and grow? Is technical fluency necessarily a drag on one's childlike imagination? In what circumstances? I take some comfort here from history's great scientists and computing's founders in figures like Feynman, Kay. Their stories certainly seem to suggest that these capacities can not only coexist, but actually amplify each other. So my question becomes, urgently, how can those of us from programming culture better cultivate that kind of resonance in ourselves?